In this next part of the talk, I'm going to be discussing what Voynichese is most likely to be and what it is not. So if we think about the possible space of solutions to the Voynich manuscript, we don't have an infinite number of things that it could be. There are some things that it's more likely to be and things that it's less likely to be, but we can exhaustively delineate the types of things that we might see. And so I think there are 6 different things that we could think of Voynichese as encoding, 6 types of system, as it were. If you can think of others, please let me know as well, because these are the 6 that we've been focusing on. So first of all, it could be non-language. It could be some sort of gibberish, some sort of hoax writing, some other type of non-linguistic system. So for this purpose, I think of a linguistic system as there being some sort of systematic representation of form and meaning. And so a non-linguistic system does not have that systematic representation. Okay, so it may look like language in some ways, but it does not have that systematic correspondence and systematic representation. So that's one possibility, and certainly one that various people have claimed. It could be a conlang, it could be a constructed language. And so we do have examples of pre-19th century conlangs, not a lot of them, but some which I'll talk about. What makes a difference between a hoax and gibberish and a conlang is that a conlang does have systematic correspondences, form meaning correspondences, systematic possibilities for communication. It's just those, the lexical items are constructed rather than occurring in natural language. Third possibility is a substitution cipher in a known language. So some sort of encipherment of a language like Latin, German, French, Italian, Greek, Persian, etc. Another possibility is that it's a more complex cipher. So not a simple substitution cipher, but something more complex, but also in a known language. It could also be some sort of unknown writing system for a known language, which I think we can treat as equivalent to a substitution cipher for our decoding purposes. And finally, Voynichese could potentially be a previously unknown language, so something that we don't have any other records of. And although there's a tradition in machine translation and so on as treating language translation as basically encipherment, going back well into the 1940s, I would treat these as different because the methods of decipherment are different in this case, in each case. So if it's a cipher of a known language, we can compare texts of known languages and work out what the system is, and by comparing it to things we already know. Whereas if this is a previously unknown language, we don't have that other sort of documentation. And so we have to use more language documentation type techniques and look purely internally to the system itself. Okay, so these are the possibilities for what Voynichese could be, but as I mentioned, some of these things are less likely than others. And I'm now going to proceed to rule out a number of these items. I think we can pretty comprehensively rule out a substitution cipher in a known language or an unknown writing system for a known language. So I treat these as equivalent. And we can rule these out simply because a lot of really smart people have been looking at Voynichese for quite a long time. Smart people who know Latin and German and French and Italian and Greek and so on and so forth, Turkish, Persian, etc. And so if this were a simple substitution cipher, we would have been able to decode it. We know how to decode substitution ciphers using frequency decoding. They're able to be looked at to decide, I do this test with my undergrads, and they can basically just look at it and work out on an intuitive basis what language or what items things are likely to be. Okay, so I think we can rule that out pretty straightforwardly. I want to talk about conlangs next. So we do have a number of pre-19th century conlangs that have extensive material. 4 of them are Balay Belen, which is a Turkish, Arabic, Persian lexicon used as a Sufi mystic language. We have Lingua Ignota, which was invented by Hildegard of Bingen. We have Formosan, which was invented in the early 1700s. And we have, and based on English, and we have Enochian as well, which was John Dee and Edward Kelly's angelic language.
And of course, we have a number of language fragments made up by kids the world over, etc. But those are not documented, unfortunately. Balai Belen is known through 3 manuscripts in different parts of the world, through a lexicon, which has some morphological information. And so we're able to say that the form of the language is this combination of Arabic, Turkish, and Persian with morphology from all 3 languages and roots of all 3 languages. Lingua ignota, on the other hand, is basically re-lexified Latin. It has Latin inflection, Latin word order, but the roots are otherwise unknown. They are made up from Hildegard of Bingen. There are also, Lingua ignota has its own writing system, which, as you can see, is one of these alphabetic substitutions. Okay, so, Enochian is somewhat like glossolalia, but has an English matrix grammar, and Formosan does too, basically, so English word order, etc. So we can very tentatively conclude, I think, that if Voynichese is a conlang, then we would expect to be able to recognize grammatical characteristics of a well-known language like Latin or German or French or Italian, or probably not English for Voynichese, but some other language in frequent use, even if we can't tell what the words mean. So we should be able to identify affixes, we should be able to find regularities in word order and things like that. And the fact that morphology has proven surprisingly difficult to elucidate in Voynichese is itself quite interesting and may speak against the probability that Voynichese is a conlang of the other types, of the type of conlang that we know from before linguists got involved in the 19th century. Okay, so I'm shading out conlang as being less likely, but I don't think we can rule it out absolutely, whereas I can think we can rule out substitution cipher pretty comprehensively. Another thing I think we can tentatively think of as less likely, even if we don't rule it out for certain, is previously unknown language. And that's simply because it's not impossible that there are languages that we have no other records of. After all, we know of language names where, as far as we know, we have no written record of them. Like Phrygian, for instance, we have 2 words of. Linear A, we have the Phaistos disc, but nothing else. We know that there were languages spoken in Europe before Indo-Europeans came, and we know that most of those languages have disappeared. But I think it's pretty unlikely that such a language would have survived in the context that we're talking about for so long. Not totally impossible. After all, there was Gothic in Crimea 1,000 years after we thought that Gothic had disappeared. So not totally impossible, but fairly unlikely. Of course, this also relates to whether we think the Voynich manuscript is a copy of an earlier manuscript or whether it was created de novo in the early 15th century. If it's a copy of an earlier manuscript, of course, that raises more possibilities for more languages and different languages and possibly other unknown languages and so on. So again, I'm not totally ruling this out, but I think it's pretty unlikely. So what does that leave? That leaves non-language gibberish or hoax writing of some sort, or not a substitution cipher, but a more complex cipher in a known language. So let me talk a little bit about ciphers now. We do have evidence of ciphers that are more complex than substitution ciphers in the relevant time period in the relevant general area. So for instance, we have de Lavin's 1379 compilation of government ciphers from Mantua, if I remember right, and they include a number of ciphers that have multiple characters for the most frequent lexical item, for the most frequent letters. They also use null characters and various other things which make frequency decoding more difficult or impossible. An interesting aside is that we don't actually have evidence that in the 15th century, Europeans used frequency decoding as a technique for decipherment. And so it's interesting that they were using ciphers that were frequency decoding proof while simultaneously not really knowing that that was a thing that they could do. So either our knowledge of this is imperfect, or the techniques of encipherment were actually ahead of the decipherment techniques for a while. That said, we have quite a lot of material around ciphers, but actually very little cipher books. We only have 2 or 3, if I remember right, and the biggest one is by Fontana. It happens to be around the same time, but this is a substitution cipher. It's a straightforward substitution cipher. The name of the book is Bellicorum Instrumentorum Liber, the book of the instruments of war, and it's basically how to make trebuchets and various other things. And it was encoded in a letter-based substitution cipher that looks like this, and it's pretty straightforward to decode. Okay, so I mentioned arguments against substitution ciphers before, but I think we can actually say some things about more complex ciphers as well. So it's probably not a simple coded substitution cipher. It's probably also not a cipher with nulls or multiply encoded letters, so not like the Kramer cipher that we saw before. Sorry, that's a typo. It should be Kramer, not Cremona. And it's also probably not a polyalphabetic cipher or a Playfair cipher, partly because polyalphabetic ciphers are known only from later, from 100 or 200 years later, but also if it's a polyalphabetic cipher where the alphabet for encipherment is changing regularly, then we would not expect to see similar words occur across different pages. And Luke is going to talk in the third part of this talk about global structure of the Voynich manuscript and global linguistic structure, which is relevant to this point as well. But the argument against ciphers and nulls and multiply encoded letters is a little more complex, and so let me go through that now. So if we have a cipher with multiply encoded letters, where the most frequent letters are encoded multiple times, that's going to cut the frequency of the most frequent letters. So in Latin and English, for instance, the most frequent letter in running text is E. And so if E is encoded in multiple ways, that's going to cut the frequency of E and make it half as frequent or a third as frequent or whatever. And you can see how that looks if you look at this dashed black line here. This is a text that was coded in Latin. And I simply used a substitution cipher with multiple substitutions for the most frequent letters. And so you can see that we still have a frequency distribution, but it starts as much lower than with either the Voynich manuscript here or uncoded Latin, which is the grey line here as well. And you can see that the Voynich manuscript actually looks somewhat similar to the frequency distribution of individual letters is quite similar in Latin and in Voynich. On the other hand, it's not just a substitution cipher, because if it were, it's highly likely we would have been able to read it. Okay, so that's the argument against multiple encoding characters. The argument against nulls is a little more complex, and I'm not so sure of the reasoning here. And so I'd welcome feedback on this, and I'm not going to stake my life on this by any means, but let me take you through it. So if we want to identify nulls, we can think about what nulls do to words. They create minimal pairs with respect to their unencoded or unenciphered word. So if I, for instance, want to make a ciphered version of cat and use a null, I'm going to use Q for the null here. I can stick Q somewhere in the word, and I therefore have a minimal pair that differs with an edit distance of 1, and that edit distance is a single addition. Now, if we think about language more generally, we can make minimal pairs through additions like this in natural language as well. So, for instance, cat and cats is a minimal pair with the addition of the plural marker s. But we also have minimal pairs that are created through substitution. And so we have something like cat and rat, for example, where the C has been substituted with R, and we made a minimal pair that way. And now if characters are null, if we had null characters, that particular character should probably make more minimal pairs through addition than through substitution.
So this assumes that nulls aren't always used, that they're sprinkled in the at random through the word. This is actually one weakness of this argument, is that we don't know how medieval users of these ciphers actually use nulls, whether they put them in particular places in a syllable, whether they use them to break up words, whether they always encoded words the same way, etc. So this is a caveat for this argument as well. But if a character is a null, we might assume that it would make more minimal pairs through addition than through substitution. And so what we can do is we can look at Voynichese characters and see what types of minimal pairs they are involved in, and whether they make what the rate of minimal pairs that are substitutive, or what minimal pairs involve addition. And we actually have 4 characters which are involved primarily in making minimal pairs through addition rather than substitution. So for the thing that's an I, it's substantial, and for Q here, which is the 4 in EVA, it's substantially different, whereas for the E, which looks like a C, and the D, which looks like an 8, those are both frequent characters, which are also, but more frequently used in addition. Okay, so and so we could look at the distribution for these. So for E, there are many different additions in various places in the word, and both finally and initially as well. So we have things that start with just the benches character or benches character plus an E. We have things word finally that have either the what looks like an 8 and a 9, or transliterated as dy, versus edy or ey, etc., etc. For D, we have alternations between Y and DY, between CH and CHD, as in a word like this versus a word that has the D in it. We also have it at the end of the word or before a common set of suffixes as well. And sometimes we have it at the beginning of a word as well, although there's some uncertainty about word breaks in some cases. Okay, so these are potential targets of nulls, but the argument around nulls is actually quite difficult to make for most Voynich characters. So just to summarize this, to give an interim summary, we've actually either ruled out strongly or considered it pretty unlikely all of the potential options, except either a more complex cipher or some sort of gibberish or hoax or non-language. And the arguments for the non-language gibberish arguments actually rely on looking at the structure of the manuscript as a whole and understanding what makes Voynichese peculiar at the sentence level or at the word and character level, which is what Luke is going to talk about in the next section now. So this wraps up part 2, and we'll go on to part 3 in a second.